Hello and welcome to SudoKanard. We're here to solve this irregular Sudoku that was created by Indian author Kumaresan for the recent WPF Sudoku Grand Prix. It was only worth 39 points, which is not a lot for irregular Sudoku. It's often a confusing variation on Sudoku and one that I kind of dread. But with these few points, I was confident I could solve it, and I did. So now I'll be trying to pull it off again. So where do we start? One important thing here is that we have 6 digits here, 6 cells that are common to one region and one row. So the leftovers, which are those 3 digits, must be the same as those 3 digits. In particular, you can see that there is a 2 somewhere here. I will be using mainly slide annotation, meaning the positions are the positions that are candidate for where such a digit goes. So we see that 7 is nowhere in here, so it has to be here in the column, in the region, but 7 is here, so 7 is locked into 2 positions in this region and on this row. And actually, this row, on this row, we could see that 7 is not here, and because of this, 7 is not here either. So we could also have used the row as a basis for logic. This 8 here is interesting. It's removed from all of those positions. So in this region, 8 can only be here or there, but there it's not either. So 8 is here. And 5 is nowhere in this part of the column, so it must be here. And an interesting point here is that with those 5s, we see that 5 can't go anywhere in here, so it must be here. It pushes the 2 into this cell, and it pushes this 5 into this cell. So a lot is happening, and then 5 is nowhere on this row, so it has to be somewhere here, but it's not here. There's already a 5 in the column, so 5 is here. And then 2 is in none of those cells, so 2 must also appear somewhere in here, but it's not here, so only 7 is allowed here, and we get a 2-5 pair there. So something similar is happening here. Those 3 cells are nowhere here. Oops. Those 3 cells must contain digits different from all 6 in here. So those 3 cells must contain the same digits as those 3 cells. So there must be a 3 somewhere here, and there must be a 9 in one of those 3 cells. And the third digit is the one that's here. And we can see that this digit is different from all of those. So this digit must be from 1, 6, and 8. But then 6 and 8 here, so 6 and 8 are also not in here, so they are also not in here, so this digit must be a 1, and here we get a 1, 3, 9 triple, with 3 excluded from this position. So now this row still needs 2, 4, and 7, so I also use some candidate notations, but first let's notice that this one has no business in those cells, so it must be here for the region. And that 8 is nowhere here, but it must be somewhere in the column, so 8 is here. So now the digits here are 3, 4, 6, and 9. So this is 3 or 4. And this row needs a 1, so 1 must be somewhere here. Perhaps I should focus on digits that are basically everywhere. For example, those 9s. Those 9s don't appear in here, so they must be somewhere here. And I'm seeing about 9. 9 is not here. It's nowhere here because of those. It's not here. So in the column, 9 must be here. Those digits here are 2, 6, and 7. So that's not a 6, that's not a 2, that's, what are those? Here we have a 1 and a 3. And those must be 2, 4, 6, and 7. And we can see that 7 is in one of those cells. And we can also see, because of this 7 and this 7, that we have a 7 somewhere here. So we have located 2 7s on those 2 rows. Well, and we can see that the 7 couldn't be anywhere else. Those are the last 2 7s in the group. No, that's not true. Oh, on this column, 7 is not here, it's not here, 7 is there. So that's a 6 and that's a 2. And on this, oh, there must be a 7 somewhere here. So we see it's not here, it's not here, not here. It's somewhere in there. And for this region, 7 is not here, not here, not here, and not there. So 7 is here, not here, 7 is here. All right. There's only this ambiguity. Do we have all 8s? Not sure about that. In this region, in this row, 8's not here. It's in one of 2 places. And in this region, it can only be here. So that's the ambiguity with 8. This region needs an 8. Not here, not here. It could be here. And actually, yes, on this column, 8 is not here, 8 is not here. So that's an 8. This row still needs 2, 4, 6, and actually only 4 goes here. This column still needs a 1 and a 3. What next? This column, oh, this one here. Puts a 9 there, eliminates this option and puts a 9 there. So this column still needs a 2, it's not here, that's a 4, and that's a 2. So here, what other digits do we need? 3 and 4. 4 is here, so 4 goes there. And 3 is still allowed everywhere, I think. So we're getting there. This row still needs 7, 2, and 4. No big restrictions on 2s and 4s. Is there anything else with 2s, actually? Oh, we see that 2 here, so 2 is somewhere in here. Oh, and that's interesting because we have a 2 somewhere here and a 2 somewhere there. So we've located 2 samples of digit 2 on those columns. So that can't be a 2 anymore. And another way of saying that is that this column can't have a 2 here, can't have a 2 here because of that, can't have a 2 here. So 2 had to be here anyway. And that's a 6. So that's not 6, that's not 6. I can still have a 6 here and a 6 there. And what can this be? We still need a 9 in this area, so and 9 can only be here, so it pushes the 8 in here and the 6 there. And that's the 3. This 3 puts the 1 down there and this 3. And now in this region, 1 is not here, 1 is not here, 1 is here. And that's the 3 on top. we're still left with 1, 4, 6. So this is 1 or 4, 4 or 6. And this one here says that one can't go anywhere in those cells, so that's the 1, that's 4, and that's 6. 4, 6 are not here, but they must appear somewhere in this region. And considering those digits, 6 is here, 4 is there. This 4 eliminates 4 in this cell, so 4 must go here, it pushes the 1 there. This one makes this a 3, this a 1, so that's the 3, that's the 8. I need a 2 on this row, not here, not here, that's the 2. Those must be 5 and 6, but there's a 6 here, there's a 5 there. This is all consistent, which is good. 1 is not here, but it must be somewhere in the column. That's here, and the last digit is a 3. This 4 makes this a 3. I need a 4 and a 9 here. There's a 9 here. I need a 5 and a 6 here. We have those digits. So 5, 6. So now that's a 2, that's a 5, that's a 4. It pushes the 2 here and the 7 there. And that's a 4, and that's the 3, I think, and that's it. All right, so really this Irregular Sudoku by Kumaresan was empty of huge struggle, as it may happen sometimes with this variant. So that was really neat. And thanks for watching this video, and see you soon on SudoKanard.